Welcome to the Computer Chronicles. I'm Stuart Chaffee, and sitting in this week for Gary Kildall is Herb Lechner of SRI. Herb, what we have up on our Apple computer here today is the Koala Micro Illustrator and my handy Koala pad here. And we see a menu of some artists' choices, and if I can, I'm going to try to communicate to you here in some computer graphics. And so far, it's working. If I get your name right. There we go, and I can even make it a little more sexy than that. We'll give you a little brighter background color, so it's a kind of more upbeat message. Herb, computer graphics is the subject of our show today, and computer graphics, in fact, involves more than just this little thing we're playing with, or even video games, which some people associate with computer graphics. There are some pretty serious applications, aren't there?
Very much so, Stuart. Computer fine art hangs in galleries right alongside of traditional art. And, of course, in the commercial area, computers aid animators and play a very important role in TV advertising today. And, of course, the basic building blocks of computer art, that is, the graphics subsystems, play a role not only in art, but in related activities such as computer-aided design and other graphic applications.
Okay, on today's program, we'll be looking at one of the newest computer graphic systems called Iris. We'll look at a computer art system called the Paint Box, and we'll meet two computer artists, real people, that is. First, let's take a look at the kind of computer art being done now on mainframe computers. Since the first light pen and graphics displays of the 1950s, computer-assisted artwork has been associated with beautiful, if mathematical, images of symmetry and abstraction. But the applications today extend far beyond repetitive patterns. With enough computing power, computer graphics can extend an artist's reach to cover the height and length of a wall, or compress the time it takes to animate something from a month to an hour. Using a digitizing tablet, MIT artist Ron McNeil chooses from a palette of colors and pre-programmed images to create a collage that exists only in the computer's memory. Before ever seeing a canvas, it undergoes some dramatic transformations. Starting with materials from different sources like photographs or three-dimensional objects, the composite can be manipulated to change in color, size, or geometric aspect. The screen-sized image shown here is only an intermediate step toward the final hard copy, a painting that is 14 feet high and 48 feet long. Like a colossal paintbrush with a memory, the giant XY plotter magnifies the completed artwork into a wall-sized mural, strip by strip and color by color. As an ingenious collaboration between digital imagery and robotics, the giant plotter is unique. But the special talents of computer graphics are increasingly used in another area of the visual arts, animation. To an art form that was once the near-exclusive province of film, computers offer a much faster method of animating images. Again, through a digitizing tablet, an artist can create a figure by drawing in just enough points to determine its size and rough shape. For a symmetrical object, all the computer needs is the outline of one side, which is then shaped into a fluid form, regenerated, and filled in with color and three-dimensional detail. The software calculates and reproduces the characteristics of light and shadow that the object would possess in 3D. Finally, to animate the drawing, the artist specifies some key camera positions from which the object is viewed in space. The program then fills in the missing frames that simulate movement between those points. Making a drawing come to life is the most tedious part of an animator's job. Fortunately, it is also readily adaptable to digital processing. The systems used to produce these images are not designed to replace artists, but to assist them. And with enough human talent, they can mimic reality in detail or expand it to the fringes of our imagination. Our guests around the table now are Michael Arendt. Michael's a computer artist and design director with Aaron Marcus & Associates in Berkeley. And next to Michael is Don McKinney, vice president with Silicon Graphics here in Mountain View in the Silicon Valley. Herb?
Michael, in your consultant role, you use all kinds of computers graphics equipment. You have a setup here today for us. Do you want to tell us a little bit about this equipment and what you're going to do?
Well, this is an 8-bit microcomputer, which is very similar to the type of computers that most of the viewers would use in their home, for instance, to play games. And we use these type of systems, for instance, to create imagery for digital directories and education software and such like that.
And what exactly do you show us how you use this system here?
Okay, well, the traditional artist tool is a brush. This is an electronic artist tool, and it's using a graphics tablet, which you see here, and an electronic pen. And with this, I can paint images and put graphics, combine graphics, photographic images, and text on the screen. I can very quickly load in an image here, for instance, to show you a raw photographic image that was input using a video digitizer, which is simply a video camera. And once I get the image into the computer...
That's an unfortunate example, by the way, Michael, but we'll go with it.
Once I get the image into the computer, then I can use this graphics tablet to take away parts of the image that I don't want. As you can see here, it's loading in this microcomputer.
What do you mean by parts of the images you don't want, Michael?
Well, for instance, maybe I want to take out a background and put in another background, or I want to take out areas where I would like to put in other types of things like text and things like that, which I'll demonstrate here. I'll show you, for instance, I'm showing you the build of an image.
Don, while Michael is working here a second, there are great memory demands, aren't there, in doing graphics? How do you accomplish that with just a small microcomputer?
Well, and really it depends on the exact amount of memory. The memory requirements really are the requirements of the amount of color that you have, and also what we call the resolution of the screen. So the higher and smoother the image appears, the more memory is required. In the case of what you'll see later today, we have approximately 3 million bytes of memory just used to store an image in real time.
Okay, Michael, I'm sorry, you're ready.
Okay, now I've taken away the background, and now I've put in a cartoon bubble here. And then I can load in another image here to show you other things that I've...
So you're loading images you've pre-prepared?
Yes, I pre-prepared these images.
How did you go about getting the old background out? Did you trace around it or something?
Yes, you can block it out with a function on the tablet using a black background blockout. And then so, as you can see, the image is slowly building here, and then I'll show you the final image that I've created. And then I can show you how you can manipulate that image other ways also.
What is the tablet you're using? Tell me how that works.
Well, it works by addressing various areas in the computer memory, and essentially it's giving it a command either to put color onto the screen or putting geometric figures on the screen like circles or grids. And you can also put text on the screen, as you see here. Here's the final image I've built, which has a combination of a photographic image. It has graphics in the background, and it has text also combined with those graphics. And I've been able to do that with this tablet. I can also, for instance, do things like turn the image upside down, or I can also flip-flop the image this way here, and then I could bring it back up. I can also invert the colors, for instance, so I can make it negative or make them in new colors. And then there are other functions on the tablet too that you can do. For instance, you can create textures with what's called electronic brushes and things like that.
Okay, well, we're moving our way up from the simple qualified to something more sophisticated, and Don, that gets us into your area. And I think you have your Iris system set up over in the other part of the studio here, so let's take a walk over and see what Iris does. Don, how does your Iris system here differ from what we've seen up until now?
Up until now, we've really been looking at microcomputers, really personal computers, and this is really a different class of machine. The biggest difference, though, that separates us out is the idea of us using custom chips developed by Silicon Graphics for our own use to do these three-dimensional calculations. This example here is the Rubik's Cube, and what's going on here is we're calculating the location of all the endpoints of all the faces so that we can rotate those in 3D and do all the hidden surface removals all in a very real-time mode. Why don't we go on to the next demonstration here to give an idea of how our machine can be used.
What kind of machine, what's the hardware we're using here, Don?
This is a terminal configuration that has a little floppy disk on top, but the basic computer that we're using here is a Motorola 68000, often used in some of the other reasonably high-performance microcomputers. The other chips that we actually have are called what we call our geometry engine, and it's a high-speed three-dimensional floating point calculation unit that runs at 6.5 million floating point operations per second. This speed we are planning to enhance to over 10 million floating point operations just in a few minutes.
What's the demo here?
This one is a series of pictures of a series of buildings where we're doing a calculation in real time. So I'm going to angle up away from the buildings, and I'm going to zoom back away. And as I'm zooming away, you can see this building going further and further back. You can see that the light sourcing is done so that the certain surfaces that are closer to the rays of sun are visible. Now what I'll do is I'll add buildings in 3D. So you can see as I move around the space, I can actually get the full panoramic effect of this block, or I can even zoom in. So I can go through areas. Let's skip on to the next. The next is...
before we get to that, Don, what would the application be, say, of something like this architectural thing you just showed me?
We have several customers that are in the AE and C market, the architectural engineering and construction business, and we have several local companies that are doing piping diagrams and piping calculations for intersections of pipes in, say, nuclear plants. Another case might be for an architectural firm that would add software to our product and sell it to the end-user architectural people for doing building design, for doing construction of faces, landscape architectural design, even an interior decorating. Use it to place desks and furniture within a given room.
Okay, tell me about this demo now.
Okay, this one is, again, it's a three-dimensional object. It's a rendering of a robot. So the first thing I'm going to do here is get it a little bit larger. And then what I'll do is I'll tip it over so you can actually look at this robot arm from the top. And I'll spin the arm around. And now as I'm closer, let me tilt it back up so you can see it from the front view. And in this case, what I'm doing is I have one button. By touching it, I can cause the shoulder to move the entire arm up and down, or I can cause another button can cause the forearm to move up and down, and in the last series, I can cause the pinchers to actually open and close, or to even grip something. An application for this might be an auto assembly plant where you're grabbing a metal part to be welded into another area.
Okay, we have time maybe for one more, and I'll load your disk for you.
Okay, this is another sophisticated 3D application where we're actually computing the location of an aircraft in flight. So the first thing that will happen is we'll be looking out the front of the airplane at a building or a hangar, and then we're going to taxi up the runway, make a right turn, taxi down the runway, make another right turn, and take off.
Okay, and you talked about the speed of about 6.5 million. What was the units?
Floating point computations per second. Most computers are measured in MIPS, and some are measured in what's called flops. And the difference being that it's either an integer mathematics or it's a floating point mathematics.
Okay, let's see what this is.
Okay, so what I'm doing now is I'm sitting at the runway. I'm going to accelerate the plane as it goes toward the building. I'm turning the rudder now using the mouse and locking in on a direction. And then I'm going to sweep around and get back onto the main runway. And now, as I'll accelerate the plane still further, raise the flaps, just like in a normal takeoff, I can switch between the viewing angle of the pilot looking out the front of the window to the viewing angle of from the tower, and now I'm off the ground.
Done. Is very impressive. Okay, if you watch television, you are familiar with computer graphics. Some of the effects you see on the computer Chronicles are in fact generated by computer. Well, we'll see a very sophisticated video computer graphic system in just a minute. Joining us now is Ann Chase, who is a freelance computer artist, and Kevin Prince. Kevin is engineering manager at MCI Quantel. Now, Ann, you played around with a picture of me at the break just before we got to the segment. That was animation, I take it, and how do you do that with this system?
Basically, I can find that animation stack in the library and show you how I set it up just by tapping. Cell by cell is how it's set up. And here you can see that I just drew the tie and rolled it up on your neck.
So you captured the real picture and then drew on top of the real picture and then just did the cell animation.
Right, cycled the animation in.
Does this machine do all that with just commands that you give it?
Yeah, basically just your artistic ability and what you can do using the capabilities of the machine.
Kevin, what are the capabilities of the machine? What kind of hardware, software is supporting this system?
Well, hardware-wise, we're based around the 68,000 processor, as previous people were talking about. But we've got a lot of dedicated hardware to do all the fast wipes, the actual painting and drawing in the system, and changing all the brush sizes, etc. It's taken us some time to develop that, but associated with that is, probably more importantly, is the actual software interaction with the user. Everything you see is obviously a very large operating system that we've had to divide for the system.
And could you show us, you mentioned drawing and brush strokes, some of the freehand capability of the system?
Basically what I'll do here is just wipe the canvas, and you can see that I'm in a paint mode. And this shows me my brush size, and I'll take a white here, and you can see that I can just paint right on the screen. I can choose a different color just by tapping and say a larger brush size, and paint over the top of that. Then I can go back and choose that mixed color right off the image and store it to use later.
Now, this is obviously much finer drawing, greater resolution than some of the earlier things we saw at the beginning of the program. That's a function of what, Kevin?
That's basically the way we do our store manipulation, the way we actually store the picture. We have various methods of mapping the image that we're actually trying to work with into the store. Very different to individual pixel operations, which the other machines will be working with.
And Paintbox is in fact in use right now in television graphics. How is it being used?
Well, most of the networks have actually got several of these systems, and they very often use the machine for their news production. And practically every night you will see some form of over-the-shoulder shot that's probably been generated on the Paintbox. But hopefully it's so good you would never notice.
Now, this system gives you the capability of mixing that which is artistically drawn with that which is real-life photograph sort of a thing. How is that done?
Well, actually, I can just go to the live source, and you can see that right now we're taking in a live video source of what we're doing, and at any time I don't even look at myself. Let's just tap something down and see what we have here. There we have me. And I can go ahead and manipulate this right now.
So you have just captured a still frame from this live coverage of what you're doing right now, and now you can paint with it.
Right, or I could, let's say I'd like to create a stencil. And just very quickly, I can go in here with a stencil medium and just outline something and fill it.
And why are you filling that now?
What I'm going to do is a cut and paste technique. This is a stencil medium that's laid over the image. What I'll do is...
This is the word processing of art. Cut and paste.
If that's it, yes. And then I'll just paste it up.
At this point we're taking a portion of that image, and we've now got, as you can see, two images.
There we are.
Twins.
I think that's a vast improvement.
That's rather incredible. And you seem to have a lot of fun doing this. Is there is there resistance to an artist, or shall we say a pure artist who's used to dealing in brushes and paints, getting comfortable with using this technology?
Maybe at first it's a little difficult to use the menu, to learn to think and actually read at the same time while you're drawing. But once you've worked with the system for a short period of time, it's just like second nature. Very simple to use, set up in artist terms.
It's clear how valuable this would be to a television media. What about the area of fine art? And is computer art catching on there too, or growing?
Definitely. Definitely. It's the wave of the future. That's what's going to be happening in art in a couple of years. In fact, it already is.
Should brush manufacturers worry?
No, no.
They're not in trouble yet.
Not yet.
Kevin, we have about a minute left. How far can you go with this technology? Will we get to the point where you could have, where we could be replaced by animated people and sync it up with words?
I sincerely hope not. The way I see it at the moment is that we're providing the means by which an artist can extend their capabilities. We can turn a reasonable artist into a good one, and an extremely good one into a superb artist. All we're doing is allowing them to create their artwork in a much shorter space of time, and in the medium in which it's required.
Well, that's fascinating. You don't exist anymore on that picture, Kevin, but we know you're here. We're all out of time. Thanks so much for being with us. Thank you for joining us on this edition of the Computer Chronicles. There was a time when Unix was an operating system used only by the computer elite, people working on mainframes like this Amdal 580, which is in fact the world's largest Unix computer system. But nowadays, Unix is showing up on personal computers. In fact, Unix is running this Radio Shack 16B. Why all the excitement about Unix? And will Unix become the next MS-DOS? We'll find out as we take a look at Unix, the operating system, on this edition of the Computer Chronicles. Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. Gary, I told a friend of mine we were doing a show on Unix, and he said to me, why in the world would you want to feature a Unix on a computer show? Now, the moral of the story is, while some computer people are talking about nothing but Unix, some PC users don't even know what Unix is. Why is there this sudden excitement about Unix?
Well, it shouldn't be sudden excitement. Unix itself has been around since the late 60s. The problem is that micros haven't had the power to support it. They haven't had the large amount of main memory, the hard disk, the fast processor, and so forth. But nowadays, micros do have that power, and so Unix becomes a serious contender for an operating system standard.
Okay, and in fact, many people are saying Unix might become the standard operating system of the future, but there are many uses of Unix going on right now. We have a report.
Developed in the late 1960s at Bell Laboratories, Unix was later adopted by the University of California for academic research and publishing. At Berkeley's History of Science department, typesetting of journals and directories is accomplished from start to finish on a network of Unix-based terminals. Why Unix? Well, apart from the fact that a major version of Unix was designed at Berkeley, it's an eminently portable system. From micro to mini to mainframe, Unix is easily adapted with few or no changes required. The typical Unix network runs on mini-computers. User-initiated tasks are distributed among computers through port selectors. But the advantages of Unix are not limited to multi-user portability. The system is also fast and powerful. Once the user has mastered its unorthodox commands, he's rewarded with some very sophisticated features, like background processing. After initiating a task, the user can go on to another one while the system continues to work on the first. Surrounding the kernel of Unix is a shell, or central command interpreter, that redirects application input and output, manipulates files, and stores command sequences. The shell structure, unlike the commands, is friendly, allowing even the first-time user to perform complex tasks. Unix users give the system high marks for its versatility. Yet up until now, it's been largely confined to a small group of specialized users. It has proven itself to them. Now it must prove itself to the rest of us.
Let me introduce you now to our first two guests. First of all, Mark Sobel. Mark is the author of a book called A Practical Guide to the Unix System. And John Massey. John is now with MIPS Computer Systems, used to be with Convergent Technologies, and used to work on Unix at Bell Labs. Gary, a lot of people don't really understand Unix. Maybe you can start by giving us a little bit of background.
Well, Unix has a very interesting history, and it really has come down from the mini-computer world into micros, where a lot of the micro operating systems have moved themselves up into the high end, and they're sort of meeting right in the middle right now. Unix carries with it the C language, the Unix file system, and the Unix interface. Now, the file system itself is what we're talking about here, but the C language is wildly successful in its area now. It's been on a lot of different operating systems. Now, the question about the user interface is still one that we have to address. It's considered unfriendly, and Mark is going to show us an example of that and how it's made more friendly, say, with the applications themselves.
Well, first, I think for people who aren't familiar with Unix, you have a lot of short commands, because Unix was designed for machines, for terminals that ran very slowly, teletypes. And a command like this will generate a lot of information that needs a little interpretation. Okay. What you're seeing more and more today is applications being built with interfaces derived from DOS. Okay, this application is called Filet, and it has a Lotus 123 type of interface.
And this takes the place of the typical interface that you'd see in, say, a standard Unix world.
Right. user calls up this program or can automatically just log in and be using this program and moves the cursor or this highlight by pressing the space bar, and there's built-in help. Press Control W and it'll tell you where you are and what you can do if you get stuck. And return just calls up what you.
So in this case, what Unix does, it's really the core of the system. It provides the services for this program to get at the file system and so forth, but really itself doesn't talk to the user.
Exactly. It also provided an environment for the developers to build Unix. And Unix, that's what one of the things Unix does best, is to allow people to generate applications such as this.
Now, one of the things that Unix has really pioneered, I think, is the idea of portability of software. That is, you can move it around to various places. And John, what do you have, any comments about the portability of Unix itself?
Yeah, that is certainly probably the most important area of Unix. Unix started on some digital equipment machines and has since been moved to literally 50 or 100 different kinds of processors. That's very important because if you're going to invest a lot of effort in building software, it's real helpful to know that you can move it around, move it from anything from personal computers through the very largest mainframes. It means you save a lot of your investment.
Now, that's also true for software designers.
It's certainly true.
Because a software designer can then take, say, a language like C and its standard runtime library, and then you write an application for it, and you can not only run on Unix, but say run on DOS or concurrent DOS.
That's true.
Or whatever.
That's true. In fact, actually, though, that's how Unix originally got moved, was that people found that you could move C programs very easily. It was the environment that was difficult to copy, and therefore people got to move Unix to other machines.
Now, one of the criticisms of Unix has been that it was unreliable, and I think all the Unix users have heard that over and over in the past years.
Mm-hmm.
What is the state of it right now in terms of, if we're talking about the core system, the file system, you want that to be very reliable. What is the current state of that?
It's actually fairly good these days. You have to understand, originally, when you got your Unix system, the normal behavior was to find a guru or wizard and chain them to the machine. Right? Therefore, when the disk broke, you would have someone to pick up the pieces and put them back together. That was, say, 1972, 73. But as Unix moved into computer centers and more people depended on it, a lot of work was done to make it a much more reliable system. And actually, today, it's used in some fairly demanding applications. One of the things that people don't realize is that actually Unix touches them through the phone system almost every day. If you ever want to get your telephone fixed, the system that keeps track of all that work is run by Unix, and it has very reliable database.
All right, when we get into something like a micro-based system where someone can kick the power cord as they're walking by now, there have been criticisms about the reliability. What happens at that point? And that's in the commercial system.
Right.
That's what people worry about.
Right, and indeed there has been a lot of work that has had to go on to make it a lot more reliable system, and it has happened.
Mark, I want to go back to your demo for a minute. From a user's point of view, you've shown me how you can sort of friendly up Unix here and make it look like MS-DOS. But from a user's point of view, then why do I care? What am I getting from this Unix-based application that I couldn't have been getting from an MS-DOS-based application?
There are two major features that Unix offers, and I would emphasize the point that everyone doesn't want Unix. Okay, if you have an MS-DOS system running an application and it's doing what you need it to do, maybe Unix is not what you need. However, Unix is a multi-user operating system. I can do a query, look at data, at the same time someone else is looking or changing the same data, someone else, and this is all on the same machine, is using a word processing system, someone is doing graphics. So it's a multi-user machine. Everyone doesn't have to fight over the one machine. It's also a multitasking operating system. I can be performing my work here while the printer is printing a report and while I'm doing some other processing in the background. So I can be doing
it's
several.
Important to also mention that that's not the only operating system in the micro world that does that. Of course, because IBM has announced TopView, which is a multitasking operating system, and of course concurrent DOS is the same sort of thing. And so we see, again, this contention that's taking place right in the middle of Unix coming down and these other operating systems coming up. And it really points out that I think that a lot of people are looking for that new facility of being able to do multitasking. And Unix is a very good way to provide that function.
If I can open up another area, which is an alternative to a multi-user environment that's talked about increasingly. It's local area networks. And I think it's important also to contrast that with a multi-user system. And I think at some point in the future, that will be a viable alternative. Right now, you don't have your hard standard network. You don't have everyone. You can't plug every computer into the same network. Right. But I think that's something to watch in the future.
Right. Now, one thing I wanted to ask also, and that's maybe John can answer this, is that let's say TopView, for example, has addressed the problem of standardized graphics interface with VDI from IBM. What's evolving in terms of UNIX standards for standardizing the graphics display?
So that at this point is hard to tell. And I guess again the reason there is found in history is that UNIX certainly was done originally for fairly slow-speed terminals. That interface is pretty well standard. UNIX has also gotten fairly standardized in the handling of regular CRTs, right? It's a normal standard interface.
But there still needs to be some work
on the graphics area, and you can particularly see that this is a period where some parts of UNIX have become standard and other parts are under a lot of heavy work. Certainly UNIX is used on anything from personal computer machines through fairly powerful single-user workstations.
John, I'm afraid I have to interrupt. We've got to move on because in just a minute we're going to meet two more UNIX experts and we're going to take a look at the new UNIX PC from Hewlett-Packard. So stay with us. Joining us now is Doug Hartman. Doug is the manager of UNIX development at Hewlett-Packard. And next to Doug, Mike Denny, UNIX consultant and the vice president and co-founder of Basis, which is a UNIX resource center in Berkeley. One of the key people in the development of UNIX is a man named Bill Joy, who's sometimes called the father of 4.2, which is the Berkeley version of UNIX. Reporter Wendy Woods has a profile of Bill Joy.
The success of Bill Joy's UNIX 4.2 can best be measured by the success of his own company. Sun Microsystems, which makes a line of UNIX 4.2-based mini-computers and workstations, has gone from 6 to over 1,000 employees in 3 years. Sun ships more than $7 million worth of equipment each month to the technical and engineering communities, which find UNIX 4.2 the ideal operating environment for their specialized software needs. But despite his success, Bill Joy isn't allowing his UNIX 4.2 to stagnate. He continues to work closely with his university roots to improve on UNIX, unlike others.
UNIX has hit the point where it's starting to get standardized by standards committees and adopted by, and really attempt to get the control of the development by major corporations like IBM and AT&T. And that inevitably involves a slowing down of the rate of change in the system.
As for the future of UNIX, he says its open source code, versatility, and ability to work on a variety of machines means it will be popular with scientists and engineers for some time.
UNIX will be important if it can deliver applications that people want to run. The technical market needs more operating system capabilities than you're likely to see from the smaller systems. So we don't really have an alternative applications delivery vehicle than Unix.
But will Unix ever make it big in the business market? Bill Joy doubts it. He says what's needed is a Unix-based business program like Lotus 123, something big and successful. And until that's written, he says, quote, I'm not super hopeful. Reporting for the Computer Chronicles, I'm Wendy Woods.
Stuart, in the last segment, we focused in on this issue of user-friendliness, I guess an overworked word. Micro users have come to expect this idea of a graphical animated communication with their programs, and one of the points of Unix being successful is to be able to do that in the micro world. Doug, we have an example of what Hewlett-Packard has done to provide a shell or that kind of an animated communication.
That's right. On our Integral PC, we have an example of using Windows menus, that sort of thing, to give people a friendlier user interface. We can select, say, a spreadsheet, and be putting the information in the spreadsheet, and while it's going on, we can be selecting other, say, graphical windows.
Now, Doug, there are other computers that don't use Unix that can do some of this stuff. We've seen, multiple windows and other machines and multitasking. What now is special about Unix?
The big thing that Unix has going for it is the compatibility with various other machines, software portability. The idea that you can take programs which are written on some other machine, bring them to another Unix-based machine with very little effort. It makes a software developer's job very easy.
And this is what we talked about earlier in terms of the C language and the standard runtime library. The idea is if an application software writer codes in a machine-independent way using, say, C and the runtime library, then it can run on Unix or it can run on concurrent DOS or under MS-DOS and things of that sort. Yes. It's a very powerful concept for software writers.
We mentioned before 4.2, which is the Berkeley version of Unix, and I'd like to clear up what may be some confusion to people. We hear about Xenix, we hear about Unix, I think you call your thing HPUX, we hear PCIX, System 3, System 5, 4.2, and so on. Why are there so many versions of Unix, and how do they differ, Mike?
Just luck. The proliferation of names besides Unix is dictated by ATT's requirement that you not call it Unix. So each manufacturer comes up with their little name for it. For the most part, it is fairly standard. A Xenix machine looks like Unix to me. It may have a few extras here and there, maybe a couple of things your favorite utility may not be there, but to move from even between the so-called Berkeley camp and the ATT Bell Labs camp of Unix, very, very strikingly the same. Equally effective.
Why do the systems programmers feel this need to make local changes? Are they social in nature? I noticed one example that I had. I came into to our computer center and I asked one of the local programmers. Said, "Well, I don't think this I/O statement is working quite right." And he got on there and made modifications to the source code and compiled it right into the system right there on the spot. So we had a different operating system right there at that very time. Is it because it's so easy to make changes to, or what?
I think everybody, adulterates their, let's say, improves the recipe that they receive from grandma, and in this case, Ma. And particular manufacturers, for example, receive the official original source code and they're implementing it on their machine, may have particularly targeted markets in mind. For example, the emphasis on networking workstations is contrasted with an emphasis on multi-user transaction machines for database management.
Now, what about AT&T, their role in this right now? Are they trying to, say, bring these versions back into one standard?
Quite apparently, AT&T would like to define the standard as System 5, 5.2, and we'll get other decimal points behind that undoubtedly. There is another kind of de facto standard out of the so-called Berkeley 4.2 standard distribution. They are, in fact, quite different code underneath. To the outside most user, they look very similar with the difference of some utilities. It's quite common for a manufacturer, probably think of a half dozen who have adopted ATT Unix, but put Berkeley utilities on top of so-called extensions.
Seems like that might be the safe place to.
But they're nipping things from Berkeley, and then there is the basic Unix itself.
Now, there's another question that comes up, I think, in the minds of many people, is that IBM has a couple of versions of Unix that they're supporting. Are they doing this just to, say, fill the market out, or are they really trying to get behind the effort in the sense that you would think of IBM and AT&T as being competitors, and it's a little strange to think that IBM might be promoting a competitor's product?
Well, and ATT uses IBM computers somewhere in the inner cockles of the organization. I think we would all get rich if we knew the answer to those questions with any confidence.
Doug, I want to ask you about your implementation of Unix on something like this. We're talking here about a $5,000 PC. In the first part of the show, we were looking at a $12,000 to $15,000 pretty high-end AT&T machine. Do we lose anything in the implementation here? Is this the same Unix?
The only thing that we've really left out is the hard disk, which would allow you to do your own program development. By leaving out the hard disk, we can reduce the cost, but still leave you enough to run applications.
Now, I read in one of the trades recently that there was talk that Commodore was going to come out with Unix at that level. I mean, kind of Mac look-alike running Unix. Is that kind of thing possible?
Certainly technology is there to do that. It's really been a question of if the applications are there to support the home end user.
I think if any kind of a rumor like that were true, they would have to be different from the standard machine you buy in the Kmart.
Imagine trying to get Unix explained to you
That's right.
at that level.
Now, if we let's go back to the core file system at this point, the kernel, I guess is what it might be called. Operating systems from the micro world right now provide multitasking, file lockout, record lockout, facilities like that. What does Unix really offer that is, I think, substantially different that will make it successful, besides its backing by AT&T?
Oh, I'd like to take that one. I think that with Unix, you've got the promise of being able to offer the same kinds of environments, same user interfaces across a broad range of computers, both at work and at home, so that you don't have to relearn everything just because you move to a different computer.
But is there anything inherent in the file system, say, as special access methods, let's say an IBM terminology, index sequential access methods, or anything really substantially different about the way files are accessed, say, from the micro world?
Technically, not necessarily, though. It is a very, very flexible sort of least common denominator, so that ISAMs can be used on top of it. Unix itself doesn't provide an ISAM, but they are around most
So maybe, let's say AT&T's backing and the number of applications and so forth that may determine the success of Unix in the future.
The 200 utilities that do handy things don't hurt.
Yeah.
Some of it is emulation, one might dare say, of Unix by MS-DOS. Other products that see concepts and try to implement them. Unix can't claim to be the sole source of such useful functionality.
Okay, gentlemen, well, there are clearly 2 points of view on whether Unix will prevail as a new kind of standard operating system, and commentator Paul Schindler has some thoughts on that.
Sure, I should be using a can opener instead of a screwdriver to open this can of tomato juice. I mean, a can opener is the appropriate tool for the job. Well, I'm one of those people who feel Unix is the wrong tool in the wrong place in the microcomputer world. Yeah, I know, I've heard all the arguments. Unix is so easy to move to new computers. Unix programs are so easy to move from computer to computer. Well, I'm sorry, but I think that's just so much bunkum. Look, let's face a few facts. Unix was developed by a bunch of brilliant programmers at Bell Laboratories. They wanted a great mini-computer environment to develop software in, and that's what they created. And that's what Unix is today, a great place to do mini-computer software. What Unix is not is what AT&T and a lot of other companies are trying to make it into, the ultimate microcomputer operating system. I don't know enough to say whether it's easy to move Unix from machine to machine, but I do know that applications written for Unix on one machine don't always work on another. There are incompatible Unix dialects galore. Unix is a user-hostile operating system, dramatically short on software. That's my opinion. I'm Paul Schindler.
In the Random Access file this week, the Consumer Electronics Show was over and there were no blockbuster new products. Commodore did show off its new 128 series and promised to ship it later this month. Commodore also displayed its new Unix machine and 2 new IBM compatibles. Probably the biggest hot new area was robots, with new personal robots being shown by several manufacturers. Tomy introduced a new robot which can be run by your personal computer, and Nintendo showed off a game-playing robot that interfaces with the game on your computer screen. There were robots with synthesized speech and robots that change their facial expressions. Atari was a last-minute exhibitor and confused the ST picture even more by showing a new 256K model, which will supposedly sell for $499. Atari also unveiled its new CD-ROM storage system. The disc holds 500 megabytes and will sell for about $500. Atari said it will ship this December. What makes you choose one computer over another? Well, performance being equal, the most important factor is the design of the keyboard. According to a study just completed by a Connecticut design firm, buyers may want bells and whistles, but they also want a simple-looking keyboard, contrasting colors on function keys, full travel keys, long space bars, and a, quote, substantial look, generally meaning thick edges. Light waves are not only replacing electrons in computer storage, but researchers at the Center for Applied Optics at the University of Alabama say light beams may soon replace electrons in the computer itself. The center's director says optical computers using photons and lasers will be smaller, use less power, and allow for three-dimensional design and more efficient parallel processing. The optical research is being funded by the Pentagon, which sees optical processing power as essential to an effective Star Wars system. Our star of the software wars is Paul Schindler, and here's his review for the week.
They say you can tell how good a word person is by whether they work the New York Times crossword puzzle in ink or in pencil. Well, I gotta tell you, I don't work it at all, but if you do, you ought to try WordMaker, a truly obscure software package from Word Associates at 55 Sutter Street in San Francisco. Now, normally we don't give addresses, but these guys aren't in the phone book, and you can't buy WordMaker in any store. This is the software package for word lovers. It makes the grandiose claim of including every word in the English language. Its search technique is a real boon for the crossword puzzle fan. If you know how long the word is and can fill in some of the letters, you can search through 100,000 words and find all those that match what you have. Now, I can't review this package without pointing out that its command menu is one of the simplest, most useful I've ever seen. This package used to cost $50, but at that price, no one wanted it, so Word Associates cut the price to $10, just over the price of a floppy. WordMaker from Word Associates, 55 Sutter Street, San Francisco. For the Computer Chronicles, I'm Paul Schindler.
Looking for a word processor and want to know what everyone else is buying? Well, here's the latest list of top sellers. Leading the pack is IBM's Writing Assistant, followed by Microsoft's Word, Bank Street Writer from Broderbund, and then PFS Write and Multimate. WordStar comes in sixth. The Bank of America and Chemical Bank are forming a joint venture with AT&T and Time Incorporated to expand home banking services into broader-based electronics services for home users. Chemical's Pronto and B of A's Home Banking now have nearly 40,000 subscribers. The Defense Department has just completed a study which says that of the 17,000 DoD computers, only 30 of them are adequately protected from unauthorized entry. The head of computer security for the Pentagon said they are currently vulnerable to any mentally unbalanced 16-year-old. Industrial robot sales are moving right along in the U.S. Sales of robots were up 71% in the past year. There are now nearly 15,000 robots at work in the United States, up from less than 10,000 just a year ago. Finally, the tough times in the computer business were evident at last week's CES show in Chicago. Lots of booth space reserved for computer companies went unused, but the space was quickly grabbed up by the makers of X-rated video cassettes. Apparently that part of the home entertainment business is doing just fine. That's it for this week's Computer Chronicles. We'll see you next time.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. Monsieur Kildall, est-ce que je peux avoir $1?
You got me on that one.
What I was asking you was, would you lend me $1? Only I was using the French language to communicate to your brain, your computer, and I guess you're programmed in the English language, so you didn't perform the program the way I hoped you would. You didn't give me the $1. The point of this little story is that our subject today is computer programming languages, Gary, and of course there are many languages you can program in, just like there are many languages we can speak in. Before we talk about these different individual programming languages, I thought you might explain the different levels of computer language.
Well, there are three major levels of computer programming languages that sort of depend upon your level of sophistication, what you're going to use the language for. The lowest level is what's called machine language, and that's the language the machine understands, the ones and the zeros. The next level up from that is what they call systems languages, and languages like the programming language C would be in that category. And those languages are used to program applications such as word processors or spreadsheets. And then the third level, the highest level, is what's called an application language or an end-user language. And those languages like Fortran, COBOL, Logo, and so forth fit into that category. And so we'll get a chance today to talk about some of those languages and see how they're used.
Okay, indeed, we'll see a demonstration of COBOL, Forth, Logo, we'll talk about Pascal. First, though, let's try to understand a bit better this problem created by having so many different programming languages. This multilingual keyboard can perform the tasks of interpreter, grammatical advisor, and artist in translating English sounds into Japanese text. The program does for human languages what most computers are incapable of doing with their own languages. Because machine codes vary from one microprocessor to another, the same programming language cannot be shared by two different computers. For example, Apple BASIC is not IBM BASIC. A language customized for one machine will not run on another. Like their human counterparts, computer programming languages differ in structure, syntax, code, and even symbols. But the lack of standard transferable code puts the programmer at a time-consuming disadvantage. After learning to write a program for one computer, he must rewrite it for another. Because of a computer's wide range of applications, languages are specialized. Fortran for science and math, COBOL for business, Logo for education. The more friendly a high-level language, the more translation it requires before it can be executed at the machine level, and correspondingly, the slower it runs. In some cases, lack of speed at the machine level is a trade-off for quick interaction with the user. Adding a third layer of complexity to computer programming is the assembly language, required to translate high-level languages into machine code. Programs written in assembly language are faster in execution, but more difficult to write than those in a high-level language. Software firms are developing more powerful, portable languages for use in micros, but as long as computer manufacturers design exclusivity into their products and languages, users are faced with the same dilemma: machines that will communicate with everyone except each other.
Plus i jazyk.
Our guests today are Paul O'Grady. Paul is Executive Vice President for Strategic Development at Microfocus, and Paul works with COBOL. And next to Paul, Dave Eisenberg, a Senior Engineer and Software Developer with Apple Computers, and Dave works with Pascal. Gary.
You know, Stuart, there have been a lot of languages around for several years that are sort of considered traditional languages, like PL1, Fortran, COBOL is a good example of that. And one of the difficulties in the small computer industry is trying to bring those down into really usable languages. Nowadays, people expect a lot more interaction in the way they deal with computer systems. And I know that Microfocus has been working on COBOL, trying to make that more of a personal orientation. So what have you done?
Well, we see ourselves, Gary, as in the business of exploding myths about COBOL. The mainframe people have myths about it that it can't run on this kind of equipment. And the microcomputer people have myths about it in the sense that they just don't like the language at all, a lot of people. What we try to do is we try to differentiate between the environment and the language itself. And the environment in the past for COBOL has been the mainframe environment. We believe that that is what has led to much dissatisfaction in that environment. What we've done here, though, with Personal COBOL, which is one of our latest products, is show what we believe is the kind of thing that can be done and which is very appealing on this kind of equipment. I've already put us into Personal COBOL. Personal COBOL is a combination of an editor, a forms generator, a checker, syntax checker, and the ability to run programs. In this case, I'm going to go straight into the forms part, and I've already created a form for us.
This is a form that you created by drawing the lines in and so forth.
Yes. Everything that you see on this screen here was created by directly keying in the lines, the text, the X's, the square brackets, the whole thing. And I did it in approximately 5 minutes or so before the program started. What I'm going to do now is to start to generate the COBOL for this, because another of the businesses that Microfocus sees itself as being in is trying to redefine the term programming. And programming for us is simply generating code in whatever way possible, the most effective way possible. In this case, we're going to generate all of the code for this screen automatically. That I'll do now. We also wrote this program so that people who have finger trouble like me never really crash the program. I hope to prove that. I'm going to create a complete program, an index program. I position the cursor as it tells me to, and we're now generating COBOL in the lower part of the screen.
Now this, traditionally, again, if you talk about traditional COBOL programming, you'd start with a program that would, you'd work out all the details of it that would produce this screen. Is that correct? Now in this case, what you've done is you've manually made the screen up by moving the cursor around, and it's doing the inverse, it's actually producing the program instead.
That is correct, yes, and we've already produced it. We've produced the COBOL for that. What I can now do is I can decide whether or not I want to save that. In this case, I'll exit without saving. I've already created the text elsewhere. as I said, some people have finger trouble, and I always have finger trouble at points like this.
Paul, you mentioned that some programmers have not liked COBOL in the past. Why is that? What is it about it that created a problem?
There is a lot of detail to the syntax. The period at the end of each COBOL statement often causes problems, but there is also the need to define records at the beginning of a program prior to getting into the guts of it, making the program do the work. However, that comes from the type of application that COBOL was designed to bear upon. Those are typically data handling applications, file manipulating applications. And for that kind of application, it is necessary to create the records to start with.
And in fact, what you worked with here, though, is again, a program generation concept. Now, if you talk about forms, you put up forms ahead of time and then you generate a COBOL program, can you also do that for data structures for accessing files, or is this something that would come up in the future?
In terms of the data structures, they're already built into the index sequential file mechanism of the COBOL, and we adhere to the COBOL standard. But yes, in the future, one can conceive of the ability to input the data structure directly into the program prior to generating it.
Dave, you work primarily with Pascal, and tell us about Pascal and why you like it. What are its special features?
One of the nicer things about Pascal is its power of expression in terms of, for a small amount of text on the screen, which is, given the right programmer, awfully readable, you can get a lot of power out of it. It allows you to express an algorithm, a method for doing a computation or some process, the way you think about it instead of having to force it into some other mold. And that's one of the advantages of COBOL for business applications. It's built for that, such that you can think in terms of a business or record problem and do it that way. Pascal is similar, but pretty much for more general purpose applications.
Pascal had several years ago a lot of interest in terms of using it as a systems language, and it was sort of touted as the all-purpose language for doing everything. What happened? Why did that not really take place?
Pascal was first designed as a language for teaching about computing and computer science, and even its inventor admitted that that was what it was for. And he's been at work lately on something called Modula, which is designed to take over from Pascal in terms of the systems area, which lets you get closer to the machine level, but still, again, have the power of expression that Pascal has.
Paul, in coming up with something like personal COBOL we think of as you say, mainframe, big corporation environment type language. What kind of use, what kind of application do you see with something like personal COBOL?
Well, we see not just the classic business data processing applications. We see personal applications such as diary application, personal filing applications, and we also see office automation applications, all being applicable to COBOL. They all require data handling and file maintenance, which COBOL was originally designed for.
I think it's also important to think of COBOL as being a system implementer's language. That is, it's not the kind of a language that you really promote as, say, an end-user language. Is that correct?
I would agree with that.
More to the kind of an individual who is going to go out and write some extensive programs and then go out and sell those programs. And so there's a whole layer of programming languages that fit in that category that maybe an end user might not even want to consider, at least until they've had some experience with programming languages.
Yes, I agree. I think none of the standard, the normally accepted programming languages are applicable for end users at this point, personally. Not even BASIC.
Okay, well, our third guest is going to talk to us about Forth, and that's coming up in just a moment. Joining us now is Elizabeth Rather. Elizabeth is president of Forth Incorporated of Hermosa Beach, California. Elizabeth, tell us about Forth. What makes that a unique programming language?
It's unique in two respects. First, it is the only language that I'm aware of that was designed from first principles to run in a small computer, doing interactive software development for real-time applications. The second area that it's unique relates to Gary's remark early in the program when he mentioned the three levels of programming, and Forth incorporates all of them. You can work right down at the machine code level when you need to. You can do system programming in Forth. In fact, the operating system that we're running on here was all written in Forth. And you can do very high-level kinds of things, very high-level application-oriented programming. For example, we have here a graphics program that is loaded, and I have a list of a large number of demo programs that I could run here. I'm going to try one of them called Logos, which draws, it's not related to the language logo, it draws our company's logo, which is a little bit chauvinistic, but the principal thing that this is illustrating, this is a rather complex figure here, and we're doing area fill, which is a fairly sophisticated graphics technique, and it's doing it very fast and very well. It's now got everything all white except for what was concealed in the little spots there, and eventually we'll be able to make even the little spots go away. But there are high-level words that put together this entire process, and I can show you some of them. I can say,
was that entirely done in Forth? As far as was it any assembly language involved in that area fill, or was that entirely done in Forth?
No, there is some assembly language.
So it's a mixture of those two.
Yes,
Forth.
and you put in as much assembly language as you need, either to control hardware directly or to make things run fast. And you notice this is a very fast program. But you have the high-level version. I can say locate logos. Locate fill, for example. This is the area fill routine, which is written in code, because area fill is something that needs to run very, very fast. So you have assembly language code here, and then we have some other words called dark and light that are what we call high level.
Part of this is assembly language you're showing us. Part of this is Forth, and the Forth statement. Is that true?
Yes, that's right. The word dark, for example, that I'm highlighting here, makes the screen go dark, like that. And it simply picks up the color and blackens the screen and then resets what the previous color was, so that when you draw something again, you draw it in whatever color it was.
So what we're saying right here, the
highlighted
line itself is Forth in this case.
Yes, that's right.
Gary, your company, Digital Research, has Logo out now.
I just happen to have a disc with me.
And maybe you could load up Logo in a minute and show us how Logo
give me some help over there
compares to these other languages. Dave, while we're waiting for Logo to boot up there, let me ask you, are there always going to be all these different languages, or are they going to merge into a smaller number?
Well, it would be nice to have an ideal language, but I don't think it'll ever really happen. Mostly because, well, for example, COBOL, which we saw earlier, is designed and used primarily for business applications. Forth is designed for real-time applications. Logo is designed for education, teaching people to program. And, well, when you discuss languages, it almost becomes a religious argument. But really, a language is just a tool, and it's like arguing, well, which is better, a hammer or a screwdriver? And you tell me what you want to do with it, and then I'll tell you which one's better.
I think that's probably the most important point about languages, is that if you use the right one for the right application, then it's the most effective thing you can do. Logo is like a lot of different interpreted languages. It gives you an immediate feedback to the work that you're doing. And what I'll do here, I'm just going to make this screen into a split screen. And I'll show you what I mean by the immediate interaction. For example, if I type forward 30, then you see the pointer, or the turtle as it's called, moves in a direction. Now that's immediate feedback to what you typed in. Now a lot of programming languages like Fortran, or let's say many Pascal versions, are what they call compiled languages, and you don't get immediate feedback. You have to go through an edit step and a compile step and maybe even linkage editing. And that requires a lot of abstraction, a lot of thinking about what you're doing. Where languages that are interactive, like Logo and Forth and other interpreters, give you immediate feedback. Now this next thing I'm going to load in here is called Blackjack. And it happens to be a demo program. You're familiar with that one? Okay. Now the reason I'm loading this one, this happens to be an example of how you use turtle graphics or graphics to draw pictures. And this particular program was written by a 13-year-old in about 3 or 4 days. Now, it was a rather precocious 13-year-old.
Yeah, your son. That's
well,
not
no,
quite
actually,
genetically superior.
It was actually his friend.
Okay.
but the point of it is that you can do things like this, like a little game of blackjack, without a great deal of effort in a in a language that's interactive and graphical in nature.
One of the nice things about these languages where you define your own words is that you can make it read fairly close to English. You can actually pick up a program and read it.
Gary, while you're playing blackjack there, most new computer users get exposed to BASIC as their kind of language, and we haven't really talked about that yet. You're showing how easy it is to do a game like this in Logo. How is it better than BASIC? What are the problems in BASIC as a programming?
Well, BASIC is historically came from Fortran and has a lot of the original problems of Fortran. Fortran is one of the, in fact, may have been the very first, I guess, high-level programming language. Recognized high-level programming language, and so BASIC sort of followed that genealogy and has a scientific orientation to it, step-by-step breakdown of the problem into simple steps that sometimes not really the best way to think about the breaking a problem apart. Now, Logo came from the MIT Learning Project, where they thought about the problem solving itself, and then the language that would be an underlying language that would be good for that. So I think BASIC is an easy language to learn, but it has its limitations as soon as you start to do anything complicated.
But BASIC was designed to be learned quickly by college undergraduates doing very simple things. It wasn't designed to do either sophisticated programs, nor was it designed to grow. And I think both Forth and Logo have the capacity to grow in the sense that you can teach them new things, and there is a learning process going on in the computer, or between the programmer and the computer, which is very similar to the learning process of teaching a small child to do new things.
Well, I think that's interesting with Logo also is that it's sort of a bait and switch tactic in the sense that you sort of get children interested in the language because of the graphics, because they think of it as a big track that they program and runs around the floor, in this case a turtle. But behind it is a language, a Lisp, which has been used for years in artificial intelligence, and all the Lisp processing that's a part of Lisp is also part of Logo. And so there's the Forth and Lisp share some foundations that are somewhat similar.
Dave, are there any new languages on the horizon, or do we have a finite number now?
The last roster of programming languages that I saw had about 700 or 800 names in it, and I don't see an end in sight. A lot of languages are designed for one specific thing. I guess you'd call them almost a toy language, except the person who invents it. So most of them I think are offshoots of the main languages like Fortran, COBOL, ALGOL, or Lisp. And yeah, as long as people have ideas for things they want to do, they'll invent a new language.
So it's a kind of evolutionary process, I think all of you said, where one language kind of builds on.
Well, I think also it's a matter of getting started as far as learning a language. Once you've learned one language, it's not very difficult to start picking up other languages, and it seems to be a threshold to get over the very first time. So I think that's an interesting thing about learning languages, that you get started at least.
Okay, well, we started and we're finished. Thank you very much for being with us, and thank you for joining us in this edition of the Computer Chronicles.